I love the tide questions. Let's do another one. If you look at this one, check this out. Every time I've done this, I've done a shift. You remember the first one I did? I said at midnight it's the highest, and then it goes through this nice little cycle. Then the next one I said, oh, it's at 1 o'clock, and then it goes through the cycle. Check this out. It says the rise and fall of the water in the ocean. The low tide is 4.2 meters, okay? And that happens at 4:30 in the morning. The high tide is at 11.8 meters. So look what happens to the graph now. The graph at, guess what? 4:30 in the morning. So think about that. That's 4.5 hours into the day, right? That's its low point. Interesting. High tide happens at 11:30. So at 11.5 hours, right? That's 11.5, right? Okay, that's the high tide. So there you go. Bada there you go. There's only a portion again of the cycle. And if you think about it, from 4.5, from 4 in the morning to 11.5, how long is that? Yeah, isn't that 7 hours? Isn't that 7 hours? Yeah, okay. So my question to you then, if that's 7 hours, how long does it take for a complete period to happen? Well, give me another 7 hours and you're back at low tide. So your period then works out to be 14 hours. Oh, that makes sense now, doesn't it? Of course. So the period of the function is 14 hours. So as soon as you get the period, you know, and I don't know what I like to do. I like to right away figure out the b value. The b value is 2 pi over 14, which is, if you think about it, pi over 7. There's your b value, ready to rock. All you got to figure out now is, yep, you got it. You got to figure out your d, your a, and your c. Okay, well, let's draw this thing out again. Now, remember, it started here. There is ground zero. There is 4.5. There's your 4.5. There's your 11.5. There's your high tide. You're starting from low tide here to be 4.2 to high tide being 11.8. So you're at 4.2 to 11.8. Check this out. So you start here at 4:30 in the morning. You rise up to the high tide, which is almost 11:30. Oh, it is at 11:30, almost noon. Okay. And then you start to cycle down. Boom. Okay. Perfect. So there's your values. All right. So find the A. The A, of course, you subtract those. Max minus the min. Okay. Over 2. So your max minus min over 2 works out to be, I got 3.8. There's your A value. So there's your amplitude, right? Find me the D value. The D value then, of course, is 11.8 plus 4.2 divided by 2. So my D value works out to be 16 divided by 2, which works out to be 8. Sweet, sweet. Now, all I need is I've got the B, I've got the A, I've got the D, I just got to find my C. Well, think about this. Didn't I shift this? Didn't I start this here and go 4.5 that way? Of course. So I shifted it 4.5 hours this way. So, okay, my C value is a shift of 4.5 hours to the right. Okay, but did you read the question? It says write an equation for the water at any time using a positive cosine function. Ah, dag nabbit. Yeah, of course. Think about it. I'm starting here. That would give me a negative cosine function. So in other words, I actually have to start here to give me a positive cosine function. But my question is then, what is that? Well, I know that. It's 11.5. My high tide is at 11.5. So my C value is not 4.5. It's 4.5 if I did a negative cosine function. But for the positive cosine function, my C value is actually 11.5 to the right. So now I can write my equation. I'm running out of room here, so I'll have to write it down here. Okay, so Writing my equation then would be very, very simple. It would be, of course, 3.8. So height as a function of time, 3.8 cos, okay, of my b value, which was, where are you? Pi over 7. Okay, got that, right? X minus, my shift is 11.5. 11.5 to the right, okay? Close the bracket off, yeah, plus my d value. Plus 8, right? Yep, there it is. Now, here's the problem. What if this particular question said, and I'm going to erase some stuff because I need some room here. What if this particular question said, with the least amount of shift? With the least amount of shift. Look how far you shifted. You shifted from here all the way to 11.5. Well, wait a second. Wouldn't this graph also come back up and give you a maximum about here? And it looks like it's closer. It looks like it's closer to my x-axis or my y-axis, isn't it? So I'm kind of curious. I wonder what that actually is. So wait a second. Wouldn't that be high tide again? That's high tide. And high tide starts from here, which is at 4.5, and goes down to my high tide was at, on the previous day, was at high tide. But wait a second, how far is that? Well, what was the period again? If you remember, the period was 14 hours. So this goes from low tide to high tide, which is only half of that. So I'm going to go back 7 hours. That's what I'm going to do, is I'm going to go back 7 hours. So I got a question for you. If I do this, what is 4.5 minus 7? Doesn't 4.5 minus 7 equal to minus 2.5? So in fact, this is at minus 2.5. So this is at minus 2.5. So if you think about that, that's in the morning on the previous day. Oh, cool. Okay, so that's my shift. So if I said h is a function of t, where this shift is the smallest possible shift from zero, from time 0, my amplitude's the same, my cosine's the same, my pi over 7 is the same, my period is the same, but my shift is now different. My shift is now x plus 2.5, which if you think about it is a smaller number, right? Plus 8. Throw that on your calculator, you'll see that those two lines are exactly the same. Pretty cool, right? Now, here we go. This says to estimate some stuff for us. So estimate the time at 1.5, estimate the depth. So again, what does 1:15 mean? That means 1:15 is PM. You're on that beautiful clock, which is a 24-hour clock. 1:15 PM means you've hit 12 o'clock noon. 1 o'clock, right, is 1,300 hours. And then, of course, it doesn't recognize a quarter of an hour. The only way it recognizes a quarter of an hour, 15 minutes, is if you actually put it in as 13.25. Okay? So you want the height at 13.25 time. Okay? Throw it into this guy. I'm going to use this guy just in case I messed up on this. I know I didn't, but I'm going to use this one anyways. Okay, 3.8 cos. There's the pi over 7. Beautiful. I'm going to put in my 13.25 here. I'm going to subtract my 11.5 here. Close off those brackets, right? Plus 8. And I'm just going to throw it into the calculator just as you see it. Okay? So here we go. 3.8 cos fraction of pi over 2, pi over 7, I should say. It should be pi over 7. Pi over 7, right? Put my next bracket down. Boom. I'm going to use my value of x time. Now, what was the time that we wanted? What was that time? I can't remember. 13.25. Okay. 13.25. minus, what did it say minus? It's going to be minus 11.5. Ay, ay, ay. Okay, minus 11.5. Right, there it is. Okay, bracket, right? Bracket again to finish that off, plus my 8. Just double check. Looks perfect to me. Punch it. Okay, here we go. Enter. I got 10.68. So its height is it going to be at 10.68? Easy peasy. Okay. Answer the question. It says to the nearest tenth of a meter. Okay. 10.68 is 10.7 meters. How pretty is that? Then this one again is your standard question where you got to do a little bit of rearranging, right? Okay. So let's do some rearranging here. Let's take this original question here. Remember, you've got a depth now. Your depth being at, it says 10 meters. So your depth is 10 meters. There's your 3.8. There's your cos of your pi over 7. X minus 11.5, right? Boom, plus 8. Let's start solving this. Subtract 8 from both sides. This makes it nice because look, that becomes, 2 equals to 3.8 cos pi over 7. Oh my goodness. Whew, I'm getting tired. X minus 11.5. Okay. Divided by 3.8. Divided by 3.8. That cancels out. There's your y1 at 2 over 3.8. There's your y2 at cos pi over 7 x minus 11.5. Okay? That's what it looks like. I have my calculator ready to go. It's on radians, so let's put them in there. Let's put the values. So the first value is going to be 2 over 3.8. Okay, so 2 over 3.8. There's my y1. My y2 has to be this guy right out here, which is, of course, cos of pi over 7. Let's put that in. Cos of second fraction pi over 7. Oh, it's beautiful. And the rest of this would be x minus 11.5. Okay, x minus 11.5, bracket, bracket. It's good to go. It's good to go. Punch it. Let's see. What's the time here? Okay, graph. And how did I get that graph? Remember, that graph was at Zoom trig. Okay, now the question is here, it says, when is this particular thing? At what time is this at this height, right? Let's go back and take a look. At what time is the water 10 meters deep? Okay, well, think about this. The water here starts, its minimum is here. It may not be at 10 meters at midnight. It's obviously going to be less. Then that means it's got to cycle through most of the day before it gets up to 10 meters. See what I mean? So your window settings might not be enough. Let's check. Boom. Look, it's out here somewhere. You got to change your window settings, otherwise you're not going to see the intersect. Okay, so let's change the window settings. Window, let's make the X window up to, I don't know, let's go 14. What would that mean? That would mean it's 2 o'clock. Okay, and boom, there's the intersect finally. Okay, second calc. Let's find the intersect 5. Move it right on over to there. There it is. Enter, enter, enter. And we find out that its intersection is at 9.23. Okay, so again, all right, 9.23, which means what is that time? So it's at, 9 o'clock, right? 9 o'clock, 0.23. Oh, man, we got to figure out the 0.23. Okay, second quit. Hit this guy here, which is your x equals 2. All right, you do your 9.23 then, right? Subtract the 9 from that. You're left with 0.23 of an hour. Multiply that by 60 minutes in 1 hour. You're looking at, you're at 9:14 in the morning. 9:14 in the morning is when it finally hits that mark. Okay, cool.